In this video, we will be dealing with how you can plan a simple experiment for investigation. Examiners may ask questions relating to this. On your question papers, examiners may want to know your knowledge, the knowledge you have acquired in a particular area. In this case, the examiners may give some short questions that may require you to plan a short experiment for the investigation. The mode or the style you will use in answering the question will depend on the marks allocation, the marks that have been allocated for that question, and the space that have been provided for you to present your answer. So you should be very critical in that. The marks allocated for that specific question and the space provided for you. So we are going to solve this sample question, followed by an examination, a past examination question on this. So we were dealing with acid-base titration. Sample question. Plan an experiment. Plan an experiment to determine the accurate concentration of two hydrochloric acid solutions, A and B, of unknown concentration using the acid-base titration method. As I said, depending on the marks allocated and the space provided. But literally, this is what is required of you. You need in this case, you need an objective for this. Our objective for this plan will be to determine the accurate concentrations of two hydrochloric acid solution A and B using the acid-base titration method. And our example will be between hydrochloric dilute hydrochloric acid plus dilute sodium hydroxide solution to give a sodium chloride plus water. This is an acid-base titration. From our objective, our apparatus and chemicals will include, we will need an eye protection and gloves. We will also need burette, 25 cm cube pipette and the filler. We will also need a 250 cm cube conical flask. We will need white tiles. We will need hydrochloric acid solution A and solution B of unknown concentrations. We will need 1 mole per dm cube sodium hydroxide solution. And finally, we will need a dropping pipette and a phenolphthalein indicator. So we will need these are the apparatus and the chemicals or reagents that are needed for this determination. Remember that the procedure I am going to outline below, including the results and the calculation, should be carried out separately for the two hydrochloric acid solutions. The procedure. The first thing you do is you will wear your eye protection and clamp a burette vertically and fill it with some of the hydrochloric acid solution, ensuring that some of the acid will run through the tap. record your initial burette reading at this point into the table that will be provided below. To how many? To 2 decimal places. Firstly, wear your eye protection and clamp a burette vertically. Fill the burette with the acid you are using, ensuring that the acid runs through the tap. Read your initial burette reading, and it should be to what? To 2 decimal places. Step number 2. Use a pipette and a pipette filler to pipette 25 cm cube of 1 mole per dm cube sodium hydroxide solution into a conical flask that is on a white tile. Step number 3. Add 4 drops of phenolphthalein indicator to the sodium hydroxide solution in the conical flask. Make sure you use the same number of drops each time. Step number 4. Slowly add the acid from the burette. While doing that, you are swelling the flask until the indicator just changes color from pink to colorless. At this time, that is the end point. Then record your final burette reading into the table to 2 decimal places. This will be your rough titration. The first titration is always the rough titration. Step number 5. Carry out 3 accurate titration by repeating step 2 to step 4 until you obtain 3 readings with concordant result with 0.1 cm cube difference. Results and calculations. Complete your result table by filling in the results you obtain for the rough titration. For the rough titration, your initial burette reading should be recorded here. For your final burette reading, it should also be recorded here. The difference, or what we call the titra, the difference between the initial burette reading and the final burette reading is your tetra. That is the volume of the acid that was used for the titration. You record it here by subtracting the initial from the final. You record it here. Then you are done. You are done with your rough titration. Then for the accurate titration, it was also carried out. Record the initial burette reading and the final burette reading and the difference. As you are doing the titration, each titration you carry out, make sure you record your readings. When you fill the burette, record the burette reading. When you reach at the end point, your final burette reading, record it. Do that for accurate titration 1, accurate titration 2, and accurate titration 3, until you have at least 3 results that 3 titration that have concordant results. That is results that are almost the same with just 0.1 cm cube difference. When you have these results on your table, the next thing you do for under your result and calculation will be to calculate the average or the mean titra of the acid used from the 3 concordant results. From this result, accurate titration 1, accurate titration 2, accurate titration 3, you will have to add them. You will have the difference of accurate 1, the difference of accurate 2, the difference of accurate 3. You add them and divide by 2 and divide by 3. Should in case only accurate 2 and accurate 3 were the concordant results, you will add the volume, the titra for accurate 2 and the titra for accurate 3 and divide by 2. By then you have your mean titra. You will have your mean titra and you record your mean titra. Now you've got your mean titra of the acid used. Number 3, you'd have to calculate the number of moles. You have to calculate the number of moles of sodium hydroxide used in the experiment. You have to write from the balance equation. You have to calculate the number of moles of sodium hydroxide. You will calculate the number of moles of sodium hydroxide. You now know the concentration of sodium hydroxide. You know the volume of sodium hydroxide. Now, to have the number of moles of sodium hydroxide, it will be concentration. Since concentration is equal to moles divided by volume in dm cube, you will convert the 25 cm cube of sodium hydroxide into dm cube. Then multiply it. You have the concentration of sodium hydroxide. You have the number of moles. Divide the number of moles of sodium hydroxide and then divide the volume of sodium hydroxide by 1000 to have it in dm cube. Then the number of moles of sodium hydroxide will be the concentration of the sodium hydroxide that was given times the volume in dm cube. You will have the number of moles of sodium hydroxide. Now, you've got the volume of sodium hydroxide. Number 4, use the moles of sodium hydroxide calculated to calculate the number of moles of the hydrochloric acid that would react with sodium hydroxide. The moles of the acid from the equation. We have got from the equation, it is 1 mole to 1 mole. The equation shows that 1 mole of sodium hydroxide reacted with 1 mole of hydrochloric acid reacted with 1 mole of sodium hydroxide. The ratio is 1 to 1. Therefore, the number of moles of sodium hydroxide will be what? The number of moles of the acid will be moles of sodium hydroxide times the number of moles of the moles that reacted, or the mole ratio. The moles of sodium hydroxide times the mole ratio, and the mole ratio is 1 to 1. So it will be moles of sodium hydroxide times 1. That will give you the moles of the acid. Now, step number 5. Use the average tetra of the acid used and the moles of the acid in this reaction to calculate the concentration of the acid. Now you have got the volume of the acid. You have got the volume of the acid. You have got the volume of the acid. You've got the volume of the. You have got the volume of the acid, and you have got the volume of. You've got. Excuse me once more. You have got the volume of the acid, the tetra. You have also got the volume, the moles of the acid. To have the concentration of the acid, since concentration is equal to moles divided by, concentration is moles divided by what? Concentration will be equal to moles all over volume. Volume in what? In dm cube. Now, you have got the volume using, you have got the volume of the acid. God has said use the average tetra of the acid and the moles of the acid to calculate the concentration of the acid. You have got the moles of the acid. You have got the average tetra, that was the volume of the acid. So you need to make it into 1 unit. The volume was in cm cube. You need to convert it to what? To dm cube by dividing it by 1000. So when you divide the volume by 1,000, you now multiply. When you divide the volume by 1,000, this will be, that will be the moles. That will be the moles divided by what? The moles divided by volume all over 1,000. The moles is equal to a volume divided by 1,000. So in that case, we will do what? It will be moles times 1,000 divided by a volume. By doing that, the concentration will be what? Moles divided by volume in dm cube will give us moles will be mole per dm cube. That will be mole per dm cube. So by doing like that, you have your conclusion. You will calculate the volume of the concentration of the acid. Here I said, after getting the volume here, the mean tetra will be here in cm cube once more. Then secondly, calculate the number of moles of sodium hydroxide used in the experiment. The number of moles of sodium hydroxide will be what? I said concentration is equal to moles all over volume. What you do here will be that the number of moles will be what? The number of moles here will be, concentration, rearranging it, concentration times what? Times the volume in dm cube. That is how you get the number. That's how you get your moles of the moles of sodium hydroxide. Then I said here that using the moles of sodium hydroxide, calculate the moles of the acid. Now, moles of sodium hydroxide, mole of sodium hydroxide times mole ratio. Moles of sodium hydroxide for the mole of acid. The moles of acid, moles of HRO, HCl. Moles of HCl will be equal to moles of the sodium hydroxide times the mole ratio. Now, you now get the moles of the acid. Now, to calculate the concentration of the acid, we now use what? We now use concentration equals to mole divided by volume. We know the moles of the acid. We know the mean tetra that we use for the titration. We will now convert the mean tetra into from cm cube to dm cube. Then divide the number of moles. Divide the number of moles by it. Or if you don't know how to do it, you can say the moles divided by the volume, the mean tetra, all over 1,000. You still get it. That is how you have the concentration for the acid. Then you will have to repeat this method again. You will have to repeat this procedure. Beginning from here, you have to repeat this procedure again. Repeat the results again the same way. Do the same calculation and calculate the concentration for the acid B. When you now have the concentration of acid B, and that of acid A, your conclusion will be this. Based on the result that will be obtained for hydrochloric acid A and hydrochloric acid B, you could either say HClA has a higher concentration than HClB, or HClA is more concentrated than HClB. Alternatively, you could say HClB has a higher concentration than HClA, or HClB is more concentrated than HClA. That is how you can plan your experiment, a simple experiment, to determine the concentration of two different acid solutions that you have been given in the lab. Once more, given two acid solutions of unknown concentration, to determine their accurate concentration, first thing, in planning the experiment, write your objective. Since they are acid, you can use acid-base titration. The method you are going to use is acid-base titration method. You can select sodium hydroxide solution as an example for that. Reaction of the acid with sodium hydroxide, acid-base titration. Your objective, you go to your apparatus and reagents. List all what you have there. List all what you have there. Then, remember, this must be the same method must be carried out for the two different acid solutions. Thirdly, the procedure. Follow the same procedure for all the acids. And result and calculations. Record your first titration should be a rough titration to know the range of your titration. Then secondly, carry out 3 accurate titrations until you have results that you have concordant results that are almost the same, but just with just a 0.1 cm cube difference. Use those concordant results to determine your tetra. That's the average tetra for the acid. Use the average. Use that. After that, the next one will be calculate the number of moles of sodium hydroxide used in the reaction. The concentration of sodium hydroxide was given. You know the 25 cm cube that was titrated into the conical flask. From that, you can use the expression concentration equals to moles all over volume. Then convert the volume to dm cube and multiply times the concentration of the sodium hydroxide. You have the number of moles. Then use the number of moles of sodium hydroxide. Acid-base titration. From the balance equation, you will know the mole ratio. Use the number of moles of sodium hydroxide times what? To have the moles of the acid. The moles of sodium hydroxide times the mole ratio based on the balance equation. When you have the moles of the acid, we have a relation concentration equals to the moles divided by the volume in dm cube. You now have the moles of the acid. You now have the average tetra of the acid that was used in the experiment. After converting the volume to dm cube, you cannot divide the moles of the acid by the volume. You have the concentration of the acid in moles per dm cube. When you do this for acid A, do it for acid B, then compare the concentration and come out with your conclusion. Thank you. Now let's go for this is a past paper. Past paper. This is past paper part. This is past paper part. The question reads: a student investigated the reaction between aqueous sodium carbonate and two different solutions of dilute hydrochloric acid A and B. The reaction is sodium carbonate aqueous plus 2 hydrochloric acid aqueous to give 2 sodium chloride plus water plus carbon dioxide. 3 experiments were carried out. Experiment number 1, using a measuring cylinder, 25 cm3 of aqueous sodium carbonate were poured into a conical flask. Thymolphthalein indicator was added to the conical flask. A burette was filled up to the 0.0 cm3 mark with solution A of dilute hydrochloric acid. A was added to the flask until the solution just changed color. That was the end point. Use the burette diagram to record the reading in the table. Now you have been given the you have been given your results. You have got your results here. You have got your result here. Initially, here, initial burette reading was initial burette reading. Your initial burette reading was a burette was filled up to what? 0.0 cm3. So your initial burette reading was what? Your initial burette reading was 0.0. Was 0.0 cm3. Now, the final burette reading here will be what? Final here will be what? Okay, you need to know the scales. The scales here shows that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a scale of 10. So now, from here, we now say here it is 13, 13.1, 13.2. So the initial, the final will be what? 13.2 cm3. 13.2 cm3. Now, you will now know the difference from there. Okay, experiment 2. Experiment 2. The difference here will be, the difference there will be, the tetra will be, the tetra here will be 13. Final minus this will be 13, 13.2. 13.2 cm3. Okay, experiment 2. Experiment 1 was repeated using methyl orange indicator instead of thymolphthalein indicator. Methyl orange is red orange in acidic solution and yellow in alkaline solution. Use the burette diagram to record the readings in the table and complete the table. Okay. Our initial burette reading here is what? Okay, this is the initial. Our initial burette reading here is what? This is experiment 2. Our initial burette reading for experiment 2, this initial and this is the final. Let's go for experiment 1 and fill. The initial burette reading for experiment 1. Experiment 1 was, initial was 0, was 0.0. The final was what? It was 13.2 for experiment 2. And what was the difference? From up here, we said the difference was 13.2. Now, experiment 2 here. From this, experiment 2, our initial burette reading is what? We said from here 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8. It's 5, 6, 7, 8. Okay. Initial burette reading for experiment 2 is 12.8. Our final Bureau reading will be this one. Okay, from that end, we titrated and it got to what? 39, 39.1, 39.2. It will be 39.2. 39.2. And what will be the difference? 12 minus this is 4. Here. 9 minus 3, that is 6. And 3 minus 1 is 2. So it will be 26.4. All in cm cube. Now, we have filled in our question number 3, question number B part, the B part of it. What color change was observed in the flask in experiment 2? You heard it very well. You heard it in an alkaline. It was what? It was, the color change that was observed here was what? Here, methyl orange is red orange in acidic solution, and the yellow in alkaline solution. So it will be yellow. Now the color change here will be yellow. It will be yellow to what? In alkaline solution, this reaction will be yellow. It will be yellow. Now, since it was orange to orange, yellow to orange, or yellow to red, something like that. Yellow to orange or red. Yellow to orange. Experiment 3. Experiment 3. Experiment 3. It reads, experiment 1 was repeated using solution B of acid instead of solution A. Now we are no longer using solution A. There are 2 acid solutions. We have already used solution A. We have got the result. Now we are doing experiment 3 using but a different acid solution, and that acid solution is solution B. Use the period diagram to record the readings in the table and complete the table. Okay, now let's go from here. Initial Bureau reading. This is 9. This is 9 here. 9, 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8, and this is 9.9. So our initial Bureau reading here will be 9.9. Now the final Bureau reading start from 16. Now it will be 16.1, 16.2, 16.3, 16.4, 16.5. So our final Bureau reading will be 16.5. What will be the difference? 15 minus 9 will be 6. And 15 minus 9, that is 6. The out here is 10. 6 minus 10 is 6. We add here 1 minus 1 is 0. Our difference is 6.6, all in cm cube. Now, that is 2 marks. D. Suggest one observation other than color change that is made when hydrochloric acid is added to sodium carbonate. Observation is the reaction that is taking place when an acid is added to a base. When the acid is added to a base, or when the base is added to an acid, the reaction between an acid and a base. When the 2 of them are combined together, what happens? From our previous studies, we said an acid, we said when we have an acid plus when an acid plus a metal carbonate, when an acid plus a metal carbonate react, the observation that you will see, metal carbonate give you the sense that what will happen, a gas is released, carbon dioxide will be released from the carbonate. When an acid reacts with a carbonate, carbon dioxide is being released. So when a gas is being released, you will observe it from what? From, you can say, bubbles of gases are being produced. Yeah. What will be the change color when this is added? We can say bubbles of gas are produced. Bubbles of gas. Bubbles of gas are seen, are observed. Either you say bubbles of gas, or you can say fizzing. Fizzing, the sound you get from the test tube. Fizzing. Or generally, you can say effervescence. An effervescence is observed. You can say an effervescence. An effervescence is observed. An effervescence is observed. Either you say bubbles of gas, or fizzing, that is the sound that comes out from the test tube, or effervescence is observed. That is the one observation other than the color that you can see when a carbonate and an acid are reacting. Now, question E part of the titration. Complete this, the sentences below. The sentence below. Experiment dash needed the largest volume of hydrochloric acid to change the color of indicator. From all these experiments, which of the experiment used the largest volume of acid? Experiment 3 used the difference of the was 63 centimeters, was 6.6. 3 was 6.6. Experiment 2 was 26. Experiment 2 was 26.4. Experiment 1 was 13.2. So which of the experiment used the largest volume of the acid for an endpoint to be attained? We had experiment 2. Experiment 2. So we can now complete our answer that experiment 2 needed the largest volume of hydrochloric acid to change color. We needed that was the largest volume that before we could get to the end point. Experiment 2. It takes us to F part of the question. The F part of the question says, what would be a more accurate method of measuring the volume of the aqueous sodium carbonate? The more accurate method of measuring this from our previous video on measuring equipment in our experimental techniques, you saw that there were some volumes, there were some apparatus that could be used for the measurement of accurate volume. Some could be used for rough measurement or quick measurement. We were using measuring cylinder, but for accurate measurement, what was recommended during our last in our previous video was we need a pipette and a bead. We need a pipette and a bead, and in this case, to measure in the measurement of what would be accurate method for the measurement or for measuring the volume of the aqueous sodium carbonate. The accurate method was they use 25 cm cube pipette. We can use 25 cm cube pipette, you use 25 cm³ pipette, or you can use a burette. A burette is good. These are the only equipment that are required for accuracy. Pipette and the burette. And in this titration, we needed but 25 cm³ pipette or a burette for accurate measurement. Now, G part of the question. What would be the effect on the result if any of the solution of sodium carbonate were warmed before adding the hydrochloric acid? Effect on the result. The major point, effect on the result. If any of the solution of sodium carbonate were warmed before adding the hydrochloric acid, give a reason. Yeah. The effect of, remember that the effect of the result was endpoint. How many number of acid are reacting with the base? The result is the result will be to know the number of moles of acid and those of the base. Now that is the only the number of moles of the base can change the result. Only the number of moles, and the number of moles can be got from what? From the concentration. Heating it will not change the concentration. Heating it will only increase or will only speed up the rate of the reaction, but will not change the result. By warming it, it will increase the rate of reaction. It will speed up the rate of reaction. It will speed up the time the result will be attained. It will help us to get to the endpoint very fast, but it will not change the endpoint. Therefore, we said there will be no effect on the result. We cannot say no effect on the result. No effect on the result. No effect on the result. No effect on the result will be noticed. Our reason is that because the concentration has not changed, because the concentration has not changed. No effect on the result because the concentration has not changed. I only said it will help to speed up by the rate of the reaction. Let's go to the H part of it. The H part of this question says, determine the ratio of volume of dilute hydrochloric acid used in experiment 1 and 3. Experiment 1, in experiment 1 we had 13.2. Experiment 3 we had 6.6. Okay, determine the ratio. Experiment 1, say experiment 1, experiment 2, experiment 3. Experiment 1, sorry please. Determine the ratio, sorry. Experiment 1 and experiment 2. Experiment 1, experiment 2. Experiment 1, we said experiment 1 has the volume. What was the volume of experiment 1? Volume. The volume here was 13.2. The volume here was 13.2. Oh. And the volume for experiment 3, sorry. The volume for experiment 3 was 6.6. 6.6. Oh, sorry. Experiment 3, sorry. Experiment 3. Let me go back. Yep. Okay. We have a 13.2 and a 6.6. Now, what will be the ratio? The ratio here will be what? Ratio 13, 6 here will go one time, and 6.6 here will go one time, and 6.6 here will go two times. Therefore, the ratio, the ratio is what? Ratio will be equal to what? 2 to 1. The ratio, therefore, the ratio will be 2 to 1. Okay, use your answer of H1 to deduce how the concentration of solution A differs from that of solution B. Okay, you now know from here we have experiment 1. Experiment 1 needed has a ratio of 2, and experiment 3 is 1. We are indirectly saying that the hydrochloric acid of A required what? Hydrochloric acid of A for required more volume to attain the endpoint. We are indirectly saying that hydrochloric acid solution A required more volume here. Experiment 1 required more volume to reach the endpoint. If more volume of the acid here was needed to reach the endpoint, it therefore means that the acid is less concentrated. Meanwhile, in experiment 3, the hydrochloric acid solution, which is solution B, required just less volume of the solution to reach the endpoint. And if just little volume of the acid was required for an endpoint to be attained, we therefore say this is highly concentrated. Solution B, we now say it is more concentrated. So in this case, we can conclude that hydrochloric acid HCl solution B is more concentrated. Is more concentrated than HCl solution A. So we now say hydrochloric acid solution B is more concentrated than hydrochloric acid solution A. Once more, the more the volume of the acid, the more the volume of the acid is required for an endpoint. It therefore means that that acid solution has a low has a lower concentration. But if less volume, if just a small volume of an acid is required for an endpoint to be attained, we therefore say that acid has a higher concentration. The same way, if you look at the ratios, experiment 1 of A has 2, meanwhile that of experiment 3 just 1. So we will need 2 of A to react with 1. In that case, 1 is more concentrated than 2. In that case, B is more concentrated than A. In that case, B has a higher concentration than 2 than A. And we are concluded by saying that hydrochloric acid solution B is more concentrated than hydrochloric acid solution A. It was 1 mark. It was just for explanation that I wanted you to understand better. Now, the I part of the equation after H1, H2, now on I, suggests a different method using standard laboratory chemicals to determine which of the solution of dilute hydrochloric acid A or B is more concentrated. Okay. Here, you are just, what is required of you here is just suggest a method using laboratory standards chemical. This is just like what I told you from the beginning, how you can determine the concentration of 2 different acids. Here, just 3 marks. You don't need to write much. You don't have much space. You have only 3 marks. So in that case, what you need to do is objective and the method. Objective and method. Our method will be what? Our method will be to determine the accurate concentration of 2 hydrochloric acid solution A and B of unknown concentration using acid-base titration. To determine the accurate concentration of 2 hydrochloric acid solution A and B of unknown concentration using the acid-base titration method. That is just that. Then, apparatus and reagent. The apparatus and the reagent. Here, as I mentioned in our previous video, in the first section of our lesson, what you need here is you need just an eye protection. You need to mention them briefly. Eye protection, the gloves, the burette, the 25 cm cube pipette and the filler, 250 cm cube conical flask, white tile, the hydrochloric acid solution A, the hydrochloric acid solution B, 1 mole per dm cube sodium hydroxide, a dropping pipette, and a phenolphthalein indicator. That is what is needed here. Once more, eye protection and gloves. A burette, 25 cm cube pipette and the filler, 250 cm cube conical flask, white tile, HCl solution A and the HCl solution B, 1 mole per dm cube sodium hydroxide, and dropping pipette with phenolphthalein indicator. Then, procedure. You can say follow the acid-base titration procedure we use in the first experiment. Or you can say pipette 25 cm cube of 1 mole per dm cube sodium hydroxide into a conical flask. Add 4 drops of phenolphthalein indicator, then slowly add acid from the burette while swirling it until you have your color change. Until the color changes from color to changes from pink to colorless. And that is just all. Then you can now add again. Repeat the procedure for 3 different experiments, accurate experiment, until you have 3 concordant results. Then results, you can say results and calculation. You can mention here, calculate mole of sodium hydroxide, calculate mole of HCl, calculate concentration of HCl. Do this and compare for solution A and solution B. Then from that we can now say conclusion. Compare concentration of A and B. That is how you can do that. I said, because there are 3 marks and there's no space, objective and method. And your objective is to determine the accurate concentration of 2 hydrochloric acid solution A and B of unknown concentration using the acid-base titration. That is acid-base titration. That is the method. The apparatus and reagent, I ask you to name all of them: the burette, 25 cm cube pipette and the filler, 250 cm cube conical flask, white tile, HCl solution A, HCl solution B, 1 mole per dm sodium hydroxide, dropping pipette and the phenolphthalein indicator. Procedure: follow the acid-base titration procedure. Results: using the results, calculate moles of sodium hydroxide, calculate moles of hydrochloric acid, calculate moles of hydrochloric acid, and use the moles of hydrochloric acid and the volume of hydrochloric acid to calculate the concentration of hydrochloric acid. Now, compare. Your conclusion will be compare concentration of A and the B. That is what you are going to do. Just about 1, 2, 1, objective and method, 2, apparatus and reagent, 3, procedure, 4, the results and calculations, and 5, your conclusions. Do that briefly because they are just 3 marks and you get it. If you do all this, you will have all your marks. So learners, it's good for you to solve many more questions on this chapter. When you do it like that, you will be okay for the exam. Thank you very much for watching. Thank you for listening. Please like, share, and subscribe for more videos. Thank you very much.